Happy Sunday. This is PFG.Live, the podcast that challenges your local gravity vector. Welcome aboard. We have Tucker from Buffalo, New York, reporting 77 degrees Fahrenheit and sunny. Go Bills. Dale from Edmonton in the Alberta is reporting 20 degrees science, 63% relative humidity in the Canada. Evils is with us. He has numbers, but 22.5 C is somewhere in there. Bill Olney from Rome, New York, home of Air Force Research Lab, says it's 73 degrees Fahrenheit and sunny. DBX near the White Plains reports winds are 160 at 6 knots, visibility 10 miles. Sky is scattered at 5,000. Temperature 2.17. Altimeter 3005. On the YouTubes, we have Carl Tauber reporting 76 degrees, partly sunny in the People's Republic of Rhode Island. We have CJ Stevens reporting 81 degrees Fahrenheit and partly sunny in East Tennessee. Welcome aboard, sir. He says, I hope everyone is enjoying their weekend, and we are. CJ also reminds you to flatten out that like button. Thank you, CJ. Who else we got here? Josh says audio is 2 green flags. Thank you. Curtis is in Sterling Heights, Michigan, where it is 78 degrees Frankenstein and sunny. Nice reports. Here in the Windham, New Hampshire, it is 76 degrees, 54% relative humidity, or is it? You will find out. So yeah, welcome aboard, everyone. We got a bunch of cool people in the Discord chat. We got DBX, Dale, Josh, Carl Tauber, Evils, Bill Olney, Proteum is here. Welcome aboard. Orjan, welcome aboard. Curtis, Tucker, Chris O. Nice to see you guys. Josh is reporting from southern Manitoba, back home, where winds are 120 at 9 knots, visibility 10 miles. Sky is broken at 1,200, overcast 1,700, temperature 2.21. Wow. Altimeter 2987. So Josh is going to need to dry his filament, and we'll talk about that today. Welcome aboard. Yeah, we had a busy week, and it was very busy. You could tell because I had no Instagram posts the whole week, which means it was like nonstop. But we had a very productive week, and I had a sudden project completion fit, which you're going to benefit from, and we will be talking about that. So the PFG report. Oh, Doug Chin. Doug is checking in. Doug says, my weather is the same as Spencer's. Yes, it is. We could measure that in hundreds of yards. Greenwood AG is checking in, expecting a high of 80 degrees Fahrenheit in southern Idaho. Welcome aboard. Yeah. So Josh says, I always need to dry around here. Well, we have some good news coming. Maybe. It might be bad news after you hear it. The PFG report. So down in the shop, we're making 4-inch PFG stones to fill orders and put some in inventory. They are going to be done for shipping on Monday. So those will be done. I know we have a customer in Canada who is patiently waiting, and they will be on their way shortly. You know what else happened this week is that people discovered the Molly sticks. We sell molybdenum in a 2-inch stick. It's called the Molly stick. And boy, we got 2 orders for multiple mollies from professional shops. That never happened before in 1 week. So we are completely cleaned out. I have to package up some more molybdenum, and we will do that. We'll take care of you. So I think you're pretty much up to date on the PFG report. Let's see. We have some community notes. So I sat down in my comfy chair. I guess it was last night, and I had my snack, and up comes on YouTube Adam Booth's A-Bomb 79's New Machine Day. And I told my wife, I said, the only thing better than New Machine Day is watching somebody else's New Machine Day. And Adam got his two brand new Milltronics machines, a slightly bigger mill and a production type CNC lathe, which I'm very excited to watch him bring up and running, because, as you know, I love lathe. If you hadn't listened to the Business of Machining podcast with John and John Saunders and John Grimsmo, they brought up the whole Saunders Lathe Works shtick that we did last week, and they had a good time. Oh, really? So Josh says that mill is identical to what I run at work, just newer control. Interesting. I did note that Adam said that mill has their brand new, newly released, fresh and shiny control. So it's going to be interesting to see what the differences are. But and that comes from Milltronics, hashtag not sponsored. Let's see. Big shout out to my friend John Betancourt, who is helping me out. John did a bunch of, besides being a cool guy, and I enjoy hanging around with John, he is also a local. He did a bunch of my plumbing for the air system in the basement shop and tied it into the rest of this. He did a great job. He's awesome. He's an awesome craftsman. But he calls me. He was here yesterday, and then he left to go get his kids and stuff. And then he calls me and he says, "I got to stop by for 30 seconds." I'm like, "Sure, come on by." And he brings me a gift, which I am wearing right now. But he brought me the this T-shirt, which I think our friend the Professor Kaplan from last week needs one of these. It says, "I like my hats aperiodic," with a picture of the aperiodic monotile known as the hat. So thank you very much. I'm wearing mine proudly. And John, you're awesome, and I appreciate it. Okay, so who else? So one of the other Adams, I forget which serial number Adam he is, Adam Brunette from Western Mass, sent me a picture. I don't have the picture here, but somebody on, I think it was Facebook Marketplace, Adam's not here to correct me, was selling a shaper, which is ironic. It was a Cincinnati shaper. It looks like it's of much later vintage, and it looked brand new. So if anybody's interested in a shaper, I'll connect you with the appropriate information. Shout out to Doug Chin, who is here right now. Thank you for everything you've done. Doug and Doug's going to figure into today's story, which you'll hear in a few minutes, but Doug also turned me on to some hygrometers that are that they don't hang on Wi-Fi, but they hang on LoRa, which is long-range 915 megahertz stuff. I just ordered some. I will be evaluating them. Doug says they're pretty good. And one of the things we like about them is they use the Sensorion sensor. So we may have something useful here. I will keep you guys posted. So thanks a lot, Doug. Let's see. I did all that. Yeah. So we're doing pretty good. As always, if you guys have any comments, questions, or concerns, feel free to pop them into the chat. We'll try to take care of them in real time. If we can't take care of them in real time, we will take it under advisement. I did get an email from Charles. Charles says, "Can your flat stones be used on surface plates like the Mitutoyo Serra stones?" Should be a period. "I know your blocks can do gauge blocks like theirs do, but would it be safe to use on my Starrett pink plate? Thanks for any info or suggestions, Charles." So Charles is saying that I guess he's comfortable using Mitutoyo Serra stones, and I'm not familiar with Serra stones, but they're a ceramic, obviously. I think I know their composition. and he wants to know if he could use those to clean a Starrett pink plate. So I can't make a specific recommendation, but I would have no problem properly using PFG stones on a Starrett pink plate or any granite surface plate. I say that cautiously because you have to prepare the stone. You have to condition the stones against each other and make sure there's no dust or grit anywhere. So, Charles, blow the stone off with compressed air. Get some solvent and clean the stone. Clean the. I said stone twice in two different contexts. Clean the surface plate with compressed air. Wipe it down with, I like to use isopropyl alcohol. Make sure it's nice and clean. Then condition your stones on each other, okay? And while you're conditioning your stones, don't do it directly over the surface plate, because if there's anything coming off the stones when they're conditioning, you don't want it dropping on the surface plate. And then I would have no problem going to town. Okay. In fact, in the history of precision ground stones from Precision Instrument Corporation, there's a story about that, and I will leave it to you to listen to the. There's a link on our product information page at the bottom, courtesy of Silo's Garage, and he did an interview with and that we heard the story about the first use of precision ground stones being conditioned on each other and then being used on a surface plate. So the short answer is, yeah, I would have no problem with it. Put it this way. If I owned a Starrett pink surface plate, I would have no problem doing that on mine. Okay? With the provisos that I have given you. Okay. We took care of that. Are there any other questions? Let's see. Yeah, so I don't know if we've ever heard more about that, Evils, but Evils put a link in the chat for light reading. So I want to do a little bit of follow-up from last week when we talked about the aperiodic non-repeating tile, monotile, the aperiodic non-repeating, what I called non-chiral monotile, because we needed more words. We had a wonderful guy, Professor Kaplan, Craig S. Kaplan, from the University of Waterloo up in Canada, one of the discoverers of the... But now I repeat myself. I'm repeating myself, but I'm doing it aperiodically. I got a nice email from him. I want to read the email. He says, I thought a bit more about tilings that might make good candidates for lap plates. Based on yesterday's conversation, I want to encourage you to take a look at the Conway-Radin pinwheel tiling. And he sends me two links, one of which is the Wikipedia link of pinwheel tiling, and another is from, I'll have to put it into the, it's from one of the other universities, and it's about the pinwheel tiling. He says, here's what you need to know about it. It's a monohedral made from copies of a single shape, and the tile shape is a simple right-angled triangle. It is not aperiodic. Two copies of the triangle make a rectangle, which makes tiles in a very repetitive way. But this particular tiling is non-periodic. Do you see the key distinction here? Nothing's stopping us from constructing periodic tilings if we want to, but we can also choose to construct these wild non-repeating arrangements. With the hat, that's this one. With the hat, you have no choice. It only makes non-periodic tilings, but it's Very much unclear whether that particular ability of the hat is at all relevant in this engineering application, even if it is severely cool. The pinwheel tiling does have long straight lines, but they're very irregular, so perhaps that's not too much of a liability. But the pinwheel tiling has one particular superpower that caused me to think of it. Think of each triangle as having a, quote, orientation based on the direction its sharp point is facing, like a compass needle. In a sense, that could be formalized mathematically. The triangles in the pinwheel tilings have every possible orientation. Looked at another way, in the limit, the edges of the triangles lie in every possible direction. It seems to me that this confusion of directions would be good for busting patterns that might otherwise form when lapping. In a hat tiling, by contrast, edges are lined up in just 6 directions. Anyway, that was just the results of a little brainstorming. Best wishes. And that was from Craig Kaplan. Thank you very much, sir. I appreciate that. And there's a picture in the chat of the pinwheel tiling. And if you guys want to study that, we will add these 2 links into the description of today's video. Also in the chat, I didn't see that go by, is a precision ground PFG stone. This is an experimental PFG stone. Do not try to order this. That Tucker has, and he's using it on his pink Starrett plate. So there you go. And the world has not ended, so I think we're going to be okay. I stone my plate aperiodically. So thank you very much, Craig. Appreciate that. And I didn't get any requests for 3D printed tiles, but we do have 3D printed tiles if anybody's interested. Okay, moving on. And no, there's no update yet on the laps themselves. I have not started lapping with them, but I will keep you guys posted. All right, I think we're caught up on questions and comments and snarky remarks. The big topic today is something that we've talked about it's something that Doug Chin and I discussed. He says it was a year ago. Was it a year ago, Doug? I don't know if it was that long ago, but months and months ago, for sure, we talked about this. And as you know, we came through a history of what we call the quest for dry filament. And we looked for ways to get our filament dry and keep our filament dry, because dry filament makes good 3D prints. And if we're making good 3D prints, we could hit the button, make our print, and get on with the next part of our process. So, hey, Lewis. So what did we do? We investigated dessicants, ways of using dessicants, dessicant containers. We then looked at containers for the filament, and we discovered, much to our chagrin, that the Sterilite containers that we discovered nicely holds 1 roll of filament also lets in a whole bunch of moisture. We did I think a very good multi-week scientific test of, 5 different containers, including the original, including ammo boxes, including a 5-gallon pail with the sealing lid, which I use for oil, some oils in the shop. And we discovered the aluminized mylar bags, which are very popular in the food storage arena. And they're awesome. They're fantastic. So, details on pfg.gg/links. But, we came down this whole road, and then it started burning in my head what Doug and I had discovered. So the way it went down was that Doug said to me one day, he says, you know, this is approximately how it went. He said, how dry is your compressed air? And I said, I don't know. I never measured it. He said, you should measure it because compressed air is dry, and we could use that for drying filament or keeping filament dry. So I grabbed a bag. It was like a Ziploc bag or something, and I took one of my feather boards that has the Sensorian sensor on it, measuring relative humidity and temperature, and put it inside the bag and just grabbed my air gun, and I started shooting my compressed air into the bag. And my eyeballs got really big because it ramped down to about 8% relative humidity. 8% relative humidity. So if you got your filament and your filament storage box down to 8% relative humidity, would you be a happy camper? I would be a happy camper. I found that running around to all of my AMSs and keeping all the AMSs below 20%, which was a reasonable number, not crazy dry, nothing for, not dry enough for some exotic filaments, it took effort, every week. I was seeing, oh, that one's coming up. It's peaking over 20%. And I'd go in and I would change the dessicants in the dessicant cartridges, and it would come back down again to maybe 12 or 14%. And then, it would start drifting back up again. And I have 7 AMSs. No, I take that back. I have 6 AMSs. So that became a dance. And so anyway, it was just, I don't know, 5, 6, 7 days ago, this all surfaced again. And I said, I am going to design a system to do this. Or it had rolled around in my head enough that I had designed a system to do this. So I sat down and I said, we're doing this. We're going to make a system that uses the compressed air. So I sat down and made an order to make our favorite yellow catalog, McMaster Carr. And in that order, I ordered what you see, in the thumbnail, which is this setup. It consists of scooch that out a little bit. It consists of a regulator, a manifold, and a bunch of needle valves. At least that's what it consists of on the front end. And then each one of those needle valves has one of these push-in connection tubes. So it's a 1/4-inch tube, and that goes to the AMS. And I'll see if I can show you the AMS installation. I will be putting out a video on this with some more details, but yeah, here it is. So essentially what we're doing is going to the back of the AMS, and just to the right, that's how I chose it, just to the right of where the filament tube exits and up a little bit, there's a nice clear spot to drill a hole. So we went ahead and took a uni bit, one of the long skinny uni bits, and drilled a hole, and it drilled beautifully cleanly, no problem. And the size of that hole was 1330 seconds, I believe. And then we were able to mount our connection to the interior of the AMS using this is called an 1/8-inch NPT connector on a swivel with a push-in, tubing attachment, right angle, 90 degrees. So it was that thing. It was a nylon washer, and it was a nut. Now we found these nuts. This was the best part. Yeah, NPT lock nut. So there's the NPT lock nut. Again, had to search McMaster-Carr, but I found it. And those are the 3 parts, and they work fantastically well. And if you do a nice clean job of drilling that hole in the back of the wall, these parts go in there. It looks like it came from the factory that way. So I was quite happy with it. And then we started hooking it up. So this is a picture of me hooking up the, actually this is a video, but I'm not going to play it, of me hooking up the regulator manifold and the very first connection to an AMS. And I have to say it worked out spectacularly well. I arbitrarily picked a flow rate by closing down the needle valve. Well, let me show you a picture of the setup here again. Yeah, that'll do it. So I would set the regulator to 10 psi. Okay, it was just, again, I wanted a relatively low value of pressure, and I wanted it to be consistent. So we picked 10 psi, and then the needle valves were closed and then opened up 2 turns, and that was the initial set point. Later, you will find that I have reduced that to 1 3/4 turns, and may further reduce that later. When we look at the numbers, you'll see why. This was a very positive result. We started seeing some extremely good numbers. Here's there's an early 17%. Now, I got very excited at 17% because in 10 minutes, it was below what I've been fighting to keep it at. Okay. Yes, I will talk about, Evil says, is there any opinion on doing this with a box of desiccant and an aquarium air pump? Yes, I will have an opinion for you coming up shortly. And Tucker asks a great question. He says, where does the air that you pump into the AMS go? Well, it's not a perfectly sealed box. So the tube that carries the filament is absolutely one place it has to go. Okay. And the flow rate that we chose is enough to escape whatever is already there. So if you put too much flow rate in there at 10 psi, yes, you're going to inflate the box. And if your latches are open, it's going to pop the door open. That is not a problem at the flow rates we're talking about. And I will quantify the flow rates for you in a minute. Okay? So by doing this, you are continuously flushing dry air through the box. Now, I know what you're saying. You're saying, well, how dry is that air? Well, we invented a test chamber that can measure the humidity, the relative humidity of the air. This is our reference, okay? And it consists of a Parmesan cheese jar. It has to be Parmesan, okay? And one of our Sensorian boards hanging in it. And there is on top of the metal, on the metal lid, we do one of our inputs from the 1/4-inch tubing, but we also put a 0.078-inch hole, which I think you'll find is approximately just under 2 millimeters. Yes, I invented a jar. Thank you very much, Dale. You're spot on. We invented a jar. So that turned into our standard, and the latest picture of our standard, this is what it looks like after everything has settled down. The air flowing out of our system is 7.6% relative humidity. We call it 8%, but we are getting, in fact, 8% relative humidity. We're going to get to that, Greenwood. I promise. I have real numbers for you. So we took that and we now wired up all the AMSs. So I have 4 AMSs on the X1Cs. I have another 2 AMSs on the single H2D. So that's 6 AMSs plus the reference jar, as I call it. And those have been running now for a full day and a half. We can call it 2 days. And the results, I'll give you the current numbers. Here we go. Last measurement, the AMSs were at 6.5%, 9.7, 11.6, 12.5, 13.1, 11.2% relative humidity. Orjan, I'll get to you in your question in a second. It works. And the best part about this is I don't have to do any maintenance. Okay? I'm not chasing dessicants. I'm not collecting used dessicant, recharging it in the oven once every couple of weeks because I have a lot of it. And just keep, constantly running around. All of that suddenly disappears. And it is automated. Now, it's crudely automated, and maybe later we'll get a little more fancy automation, but it is working. So what is the relative humidity of the air at 20.1 bar again? 3%. Okay, so let's discuss what's going on here. I think this is actually pretty important. So the first epiphany is that an air compressor is an air dryer. So let's take a quick vote. How many people are out in podcast land have an air compressor in the shop? Okay. Second question. How many people that have an air compressor ever drain their tank? Okay. Anybody ever drain their tank? Dale uses auto drains. Yep. Let me ask it a different way. Proteum's typing here. He has a compressor and an auto drain. Excellent. How many people with a compressor would ever consider never draining the tank? So I think we know the answer to that. So you know that the act of compressing air causes the moisture to drop out of it. Yeah, Proteum says, seeing as how much water comes out of it, it would be a water tank shortly. Yeah, it would. So the act of compressing the air raises the dew point above room temperature, which causes everything to condense out. So your air compressor is an air dryer. We roughly estimate that the air, let's see. Doug says you never drain your tank. Yes, well, we'll explain why in a minute. CJ says one went boom next to my wife. It was a used 80-gallon, and it blew a quarter-size hole from rust. Ow. Yeah, drain your tanks, people, for the tank's sake. But let's estimate. We're going to do a quick estimate of what is the relative humidity of air coming out of your compressor with no particular effort, okay, to drying that air. My rough guess, and I talked to Doug about this when he was over the other night, is 20%. Just having an air compressor and having, air available, that air is likely about 20% relative humidity. Now, if that sounds unimpressive to you, it's because you're Proteum and you live in Tucson, Arizona, or you're Dale and you live in Edmonton, Alberta, where it is dry all the time. But if you live in New England, like right now, it's 55%. Well, what is it for real? It's 54% relative humidity outside. So getting to 20% relative humidity is a pretty good first step. You then can dry that air further. Now, there's a bunch of ways to do that. And is anybody here into automotive painting? Okay. If you use an air compressor to provide air for a spray gun for painting, frequently those guns want to have that air be very dry and very well filtered. So because of that, and because auto painting is pretty common, and it is at the hobby level also, there's a lot of things out there to dry your air. We were just talking about this in the pre-show. I think, Dale, you said for sub $1,000 you can get an air dryer. I had an air dryer that it worked fine. It was obviously Chinese made, and it was not pretty, and it was a little junky inside. You know what? It actually worked. So, and that was 2 compressors ago. So if you have an air dryer on your system, you can get down to some pretty low numbers. The air dryer on my system, let me just show you a picture of what we're dealing with here. I know you do not have to have a super fancy compressor and a super fancy dryer. This is a Kaiser. It's a rotary screw compressor, which has little to do with what we're trying to do. But inside, built in, is, in fact, a refrigerating type air dryer. And the cool thing is that as it pulls water out, there's a little tiny reservoir inside the compressor, and when it senses that reservoir fill up, it will shoot that water out down a line, which if you look at this picture, you'll see there's a 4-gallon, water cooler container, and I have to empty that every few months. When it gets up to about half or 2/3 full, I take it and I dump it. So that's my system. But any system that has additional drying is going to get the air down to a much lower number. So this 8% that I'm showing you is not crazy, okay? And it is dependent upon the temperature that the system uses. And I'm going to share some data with you in a second. Yeah, so Evil says, I am an amateur car painter, oil on canvas. I use cobalt-based dryer. So, yeah, Greenwood AG also says, plasma table air needs to be very dry, which helps increase the consumable life. So so drying the air coming out of a compressor is not unusual, and it's sort of the next step, and you can expect 8% type numbers. Let's take a quick look at the I always have to laugh. I told Doug, I was talking to Doug yesterday, and I said, I'll get the numbers off of my air compressors webpage. So if you have A-Bomb probably has a similar thing in he has, I think, the Air Tower, it's called. There's an Air Tower, Air Center. I think he has the Air Tower, and the Air Center is a slightly different one, but they're basically a stack of compressor, tank, dryer. It's all in one housing. I do not have that because I wanted to push the tank under the stairs, which I did. And it's a great use of space. So in this particular case, there's a picture of the graphs available on my compressor's webpage. And what it's showing is there's a use of air. That's the sloped line on the left. And then it pumps up to the new pressure, and then it continues. The important line is the blue one, which is the PSI of the tank, and you can see it drifted down below 120. When it hit 115, it turned on the compressor and it pumped back up to 125. So I took the slope of that line, and that determined how much air I was using. I'm going to share that with you in 1 second. And then the next thing to look at, it's a little confusing how they labeled it, but this is the temperature of the refrigerated portion of the air dryer, and it's oscillating between 40 degrees when it's finished cooling things off in the refrigerator and 60 degrees, and then it turns on the little refrigeration system. So basically it's oscillating around 50 degrees Fahrenheit. And if you take compressed air and you put it through, which is going to be warm, okay, and you put it through this 50 degree Fahrenheit cooling system, it will drop out more moisture. Okay, you'll get more condensation, and you will end up with drier air. That's how it works. Protium says, are you still going to keep dessicants in the AMS for days that you leave your compressor off, vacations, weekends off, etc.? That's a good question, and I appreciate that. The answer is no, because my system, my compressor, and the whole system, I intend and designed it to be on full time. So I don't turn the compressor off. I have extracted all dessicants from my AMSs. There are no dessicants in use. I suppose if I had to shut down the compressor, or chose for some reason to shut down the compressor, I could run around and put, dessicants in. But my intent and the design of my system is that my compressed air is up all the time. And that's because it gets used in the basement in the 3D printing department. It gets used in the shop. It gets used in the electronic lab. So I don't tend to turn the compressor on and off. So I leave it on. So from these graphs, I was able to start deriving the numbers. And I'm going to give you the numbers. Yeah. Yeah. Whole house air. I joke. I say, our house has hot water, cold water, and compressed air available everywhere. So let's see. I did a quick calculation on the whole system use for this new low flow drying system, and the answer was 0.2 cubic feet per minute. Okay, and it's the slope of the curve. In part, it's the slope of the curve in the upper graph here. So 0.2 cubic feet per minute is the calculation of what I'm using everywhere. Okay, and that comes out to about 0.03 cubic feet per minute per line coming off of my my manifold. So, there's the manifold. So each one of those lines is approximately 0.03 cubic feet per minute. And each one of those lines is delivering 8% air. Now, so from having observed the system for at least 24 hours, closer to 36 hours, I have observed a few things. One is that everything takes a long time for the humidity to come down. It's not like an instantaneous thing because the flow rate is very small. It's small because compressed airflow costs you money. I'm going to talk about how much money that is in a second. So the time constant, even in the control jar, okay, even in the control jar, it took a couple of hours for the relative humidity in the control jar to come down to the 8% number that it reads now. And one of the reasons is that I took a fresh Sensorion board out of inventory. I snapped it into one of my Sensorion board cases, which is on the website if you want one. And there's moisture in that piece of plastic. So the case of the Sensorion board has brought moisture into the jar. All of that stuff has to settle down. Dale got it. He says you had to try the case. Yeah, I had to try the case. Protium says it'll be interesting to see if the AMS farthest from the valve gets slightly less dry over time. Okay, we have to talk about your mental model for when you're looking at this stuff. When you look at an AMS, okay, let me see if I have a better picture of just an AMS. Not everybody has an AMS in their life. Let's just describe it. Yeah, here's a good picture. Okay. So the AMS is made out of plastic, and it contains spools that are made out of plastic, and it contains filament, which is made out of plastic, and the thing we're trying to dry is the filament. But guess what? The spools contain moisture because they're made of plastic, except for the cardboard ones, which contain moisture. And the AMS housing itself, made out of plastic, it contains moisture. So when you look at these things that are made out of plastic, I just want you to see sponges. Okay? So you have a sponge box with a bunch of sponges in it, and you're trying to control the moisture. That's what's going on here. So the control jar, which is visible in the center of this photo, the control jar is made out of metal and glass. And from our research and measurements and experiments, we figured out that those are the things that do not let moisture pass through. Plastic does. So your AMS plastic housing lets moisture through. There's like zero question about this. So part of the long tails in these numbers is that all of this plastic is drying out. So what I've observed is that you drop from whatever internal relative humidity you were at, you could drop to 20% pretty quickly, and then it's a very long tail because the plastic of everything is dumping moisture from the plastic into the drier air. So Paul says, not that those numbers suggest that there's a leak, but have you checked for leaks? First of all, there has to be a leak in the AMS for this system to work, right? We're pushing dry air in. It has to leave, or otherwise we're building a pressure vessel. So there is a leak, okay, in the AMS, but what we've observed by experiment and research is that plastic is full of holes for moisture to march through. And if you go back to the paper that we used when we were looking at containers, the paper ranks materials for containers and how moisture, H2O, marches through them. And the number one thing is just H2O molecules marching through a plastic housing. It was higher than helium. It was higher than helium. Think about that. The porosity of a plastic container to moisture is higher than helium, which is the tiniest molecule, except for hydrogen, that you're going to deal with. Okay, I got excited there. Sorry, I'll calm down. I'm just trying to catch up with an argument that's going on in chat. Protium says, I meant that moisture will likely collect at the end of the manifold without a drain. Okay, so let's track what's going on here, okay? So we have air, dry air coming in. Dry meaning 8% relative humidity air. It's marching into the AMS, and it's just bleeding in, and it's constantly pushing out the previously moist air, and that's how it's drying the air in the AMS, the plastic of the AMS, the plastic of the spools, and the plastic of the filament. That the moisture that was there is leaving in gas. It's leaving in air that's leaking out of the system. Okay? And it is the continuous flow of the dry air that's keeping everything dry. Does that make sense? So there is no worries about moisture collecting in the manifold or in the regulator. Does that make sense? Is there anybody going to wave a fist at me? I don't think so. Okay, so that is the nature. That is the nature of the system. But when you look at the plastic, I just want you to see sponges. If it's made of plastic, it's a sponge. So what's our challenge? Our challenge is when we go to heat our filament up in the nozzle, we don't want any moisture there because it's going to turn to steam and make bubbles, and it's going to make the prints lousy. That's the whole. Remember, that's the whole goal here, is not to have that. Protium says, I always put drains at the end of my drops for the air system because they always collect a small amount of moisture. So that's an interesting question, and maybe when the plumber is here, John, and we're going to do. Oh, well, the other thing is that the system is currently temporarily connected with an air hose to some of my drops, and we're going to be putting in a permanent pipe that's going to feed this. We'll put in a trap. It's a good exercise to see what's going on. So good point. Thank you, Protium, and it will help us maintain a perfect dryness. Let's see. We want to minimize flow because flow is money. Okay. If the system had higher flow rates, would it keep things drier? Answer: yes. Or it would, let me say it differently. It would dry things faster. So there's a balance, right? And for us, we want something that runs 24/7, and we don't have to think about it anymore, and keeps our filaments all below 15%. That's just a number. Yeah. Protium correctly says, once it's fully, in quotes, dry, you just need positive pressure. And there is positive pressure. It's just a teeny, itty bitty, tiny bit of positive pressure. And I did accidentally open one of the needle valves a little bit too much, and you could see the lid popping open on the AMS. So we don't want to get too crazy. Okay, so Evils is making a point that you need continuous flow to get rid of what's going through the plastic. Yes. So there's a flux of moisture that wants to penetrate through the plastic one way, and you're putting dry air and a very teeny itty bitty bit of positive pressure the other way. And without the airflow, the positive pressure, yeah, Protium's got it. Without the airflow, that teeny itty bitty bit of airflow that we're forcing into the system, you wouldn't have the positive pressure. It's not big numbers. So let's talk about money. Okay, I estimated that at 0.2 CFM in that system, and based on typical electrical costs, and based on the published numbers from Kaiser for that compressor, that operating this system, as you see here, with 7 lines, is going to cost me $78 a year in electric costs. Totally worth it. Totally worth it. And then if I get bored with my control unit, I could turn that off, which I probably won't. But I also have solar panels, so my electrical costs are actually half that, but we'll leave it there for the moment. Call it $80 a year. Totally worth it. If I spend an hour a month dealing with dessicants, and I only have to pay $80 a year to not deal with dessicants, I'm in. So I think it's a huge win. Now, what are some of the downfalls? we'll get to that in a minute. You'll also notice that on this board, okay, that I put up on the wall, there's plenty of room for other things. I plan to do some more automation. Like I want to be able to turn the system on or off based on parameters. For example, if I have sensors in each AMS and they are all reporting below 15% relative humidity, turn the system off. So I'm working on that. But right now we've hit a really nice milestone that I could live with for quite a while before we get to that. But there's room for complication, which is what we're all about. Josh asks, is this enough pressure to be audible? That was an interesting question. If you put your ear near the regulator, you can hear something. Okay? And if you take your finger and you put it on top of the control jar, right? And you close up the little bleed hole, you can get it to puff, right? You could feel a teeny bit of flow. So insignificant as far as I'm concerned. The sounds associated with this, insignificant. How much? Okay, so interesting. How much of an interruption is opening the top of the AMS? So it's amazingly little interruption compared to when I was using Dessicants. So when I was watching the Sensorion, and the Sensorion board is pretty rapid response. Okay, I'd say it has a 1 minute, not even. It has like a half a minute, 30-second time constant. It's like settled in 30 seconds. So when you open the AMS and you change spools and stuff and you close the AMS, it takes some time to settle. It takes less time to settle with this system, with the low flow air system, than it did with Dessicant by a large margin. It's way faster. So those are okay. So we covered the costs involved. All right. What else? So we talked about automation that's potentially coming. I told you that the temporary rubber hose going to the dry air system, which should scare you a little bit, by the way. Doug Chin quipped that I'm also drying out my hose, and he's right. Except we are monitoring the actual, temperature, humidity, and we are getting 8% regardless. Tucker says, do you need more beta testers for this product? So, well, it's not a product, and I'm not productizing it, but Tuck, I will help you get up and running with this. This is not difficult. The only thing you need that you don't have is a dryer. So now I want to talk a little bit about Protium. So I don't know about those things. Protium says it sounds like finding a dentist air compressor on eBay might be the way for home gamers to be able to do this. He says they're super dry and very quiet. Okay. And if you have a Parmesan jar and a Sensorion board, you could find out how dry. We'll talk about this in the after show. One of the benefits of being with us live and on the after show is we talk about all this stuff for hours more. Let's talk about alternatives. So you don't have a nice compressor and a dryer, okay, that you can use. What can you do? Well, you could use compressor only. That gets you to 20% roughly. You could use compressor followed by a big desiccant container. Like they actually sell cartridges that are meant to go in airlines. I don't think they're meant to not have another type of dryer before it. But because this is such a low flow rate, you could use a bucket of desiccant as your dryer for this application. And you can check your bucket of desiccant for its moisture content by weighing it. So besides the color, the color change. So there is a way to make your own dryer if you have a compressor. What if you don't have a compressor? If you don't have a compressor at all, you need a compressor. So you can get the tiniest compressor, because again, you don't need much flow rate here, and you could probably make it work. So this is just physics, okay? You compress air, you're going to drop water out of it. You chill the air, you're going to drop water out of it. You're going to get to dry air, you're going to bleed the dry air through the system, and you've eliminated the need for dessicants. And I am so thrilled to not have to run around and think about it anymore. The other thing it does, Evil says, I think an aquarium air pump should supply enough flow. This is a matter of experimentation, okay? The other thing that's important for me in my lab is I have to, I'll get a message from a client that I'm working with. Well, and I am. We're doing some drone parts, right? Experimental research, trying different designs. And they'll say, we have a new model. We need parts, and we need them by, day after tomorrow. I have to be able to go downstairs and push print. I don't want to be wondering what's wet, what's dry, et cetera, okay? So big win. I'm happy. That is the low flow air drying system. No copyright intended. No patents filed. It's just physics, and it's working awesomely well. Now, I do have the McMaster-Carr part numbers for all of this stuff. And I will put, let's see if I can find that photo. I may have to work on it, but I will make that available also. Is that it? I found it. So let's put it up and let's make it big. So if you want to take a screenshot, there's only one difference here, and that is I did not put the 90-degree right angle swivel connection on this list. It has a straight through connection. I really like the 90-degree swivel type. I just haven't looked for it and substituted it. So that one is bracket, standard wall bracket. Here it is. Push to connect tube fitting. So this bottom one is a straight through. I think I would prefer to use the other one, which I don't have a number for. But anyway, there's your list. All of it came from McMaster-Carr. Tucker says, does this also remove the need for the initial blast furnace drying a filament? I assume not, but others may wonder. Thank you for bringing that question up. This is very important. No, it does not obviate the need for a drying oven, and I'll tell you why. We also proved, like I bought specifically for the experiment, I bought 4 spools of filament from Polymaker. They were PETG, and Polymaker has some weird language in their on their website that says, only dry this filament if there is a moisture problem. Well, that's a pretty stupid thing to say, because that implies that you've had a failed print already with their filament. So when filament comes in, it gets dried. We assume all filament is wet. So I bought 4 rolls of the Polymaker PETG, and it was all sealed, all nice, all wonderful. And this is what 6 grams of water looks like. And 6 grams of water is what came out of every spool. Okay? So, as my friend Doug said when I showed that to him, he said, that's wet. I'm like, yeah, that's wet. So we dry everything that comes into the shop gets dried. Now, once it's dried, it has 2 places to go. One place is an aluminized Mylar bag, okay, sealed. The second place it can go is into one of our AMSs, which is already hooked up to our low flow air drying system. So that's our procedure. So yes, we still need the lab oven. Evil says, how do we know water is the only volatile that is lost in that process? We don't. Proteum says, instead of storing in Mylar, could you go back to 5-gallon buckets and put a purge in there as well and just let it slowly dry until you're ready? Yes. In fact, this is what Doug Chin does. He does not oven dry his filament. He throws it into a container which is dried by various means, dessicants or other, and then it lets it sit there for weeks, and that's what he counts on. So yes, I also have a large container which I could put another one of these airlines up to and create another low airflow dried container. And I seem to recall from when I was in the semiconductor world that this was normal. Like they had these glass cabinets that had some sort of bleed feeding into them. Like somewhere in the dark recesses of my mind, I think that was done normally. Greenwood says, much easier than the new AMS models that dry. I won't have to periodically stow the filament on the spools so they could rotate as the AMS dries the filament. So, yeah, or you just use the AMS feature to be the oven, right? You dry the spools, but once they're dry, you can keep them dry. Evil says, I'm wondering about daisy chaining pressure tight containers. Yeah, it's a good thing to wonder about. I thought about that, and it's less efficient, but think about it. I mean, it's something to think about. Orjan says, does introducing dry compressed air into the drying oven accelerate the drying process? And the answer is, it should. So, should I run an airline over to my oven? Not only should I, when I bought it, it was plumbed for gas input. So, I don't have to do a lot to do that. Will I do that? I don't think so. I don't think it buys you a ton, but if you want to do it, have a ball. Yeah, let's see. Okay, so I think we did it. That is the low flow air drying system that was conceived, what, Doug, a year ago? And implemented this week. And I could not be happier. This is awesome. I urge you guys to look into it. I don't have, except for cost, except for maybe the compressor running a few more times per day than it might otherwise. There's no downsides. It's just fantastic. Yeah, we did it. Okay, we're a little bit over. Yeah, Chris O says, yeah, we have those cabinets at work, but with nitrogen, dry nitrogen and a little O2. You could breathe that stuff, dry nitrogen, with just the right amount of O2. That sounds quite breathable. You don't want to asphyxiate the lab personnel. That would be bad. Well, guys, thanks for being here. Keep your filament dry. Keep your AMSs drier with the new system. I've given you the McMaster-Carr part numbers. We're talking about it in the 3D printing channel. We have a thread called Low Airflow AMS Drying System. If you want to talk about this system, that's the place to go do it. If you have any other questions, you know where to find me. We should be around next week. I don't think there's any impediments to PFGing it. Let's see. Nope. We'll see you next week. In the meantime, get flat, stay flat, and dry, and we'll see you next week.